Okay, in this video we are going to discuss ellipses. So first let's get into the definition of an ellipse. And it is going to be all the points in a plane whose sum of the distances between two of these points, these fixed points that we're going to call foci. Okay, so with a parabola we had one fixed point called a focus. Here we've got two of those, so the plural of focus is foci. The idea is if I picked any point on this ellipse and I did a straight line distance to each one of these points from that point on the ellipse, that distance, the sum of those two different distances as I make my way around the ellipse is always the same. Okay, whatever that distance is to this point plus the distance to the other point, that the sum of those two distances are always going to be the same as I go around this ellipse. Okay. So we've got a couple of equations here, and I'm going to talk about the difference. And it's basically that what you want to look for is the bigger number underneath the x or is it underneath the y? So the condition down here stays the same for both of these columns. A has to be greater than b. They both have to be greater than 0. It's the same condition here. What I want you to notice is on this one on the left, that means that the number underneath x is the bigger number, and over here the number underneath y would be the bigger number. What that determines is kind of the orientation of the ellipse. Is it going to be a horizontal ellipse or a vertical ellipse? And so, like the vertices are going to be the point that we extend on the we're going to call the major axis, which is like the way that the ellipse is oriented. And notice if the ellipse is oriented horizontally, that's going to be an x coordinate. If it's oriented vertically, it's going to be a y coordinate. The major axis is just the length that you have, the total stretch that you have along the horizontal length or the vertical length, depending on which way the orientation is. The length of the minor axis is the total stretch in the opposite axis. The equation for the foci is the same regardless. It's c squared equals a squared minus b squared. Now again, the number underneath x squared and y squared, those are a squared and b squared. So when we go to find the foci, we're simply going to take those numbers, subtract them, bigger minus smaller, subtract those two things, and then take the square root. Now we'll have c. And the positive and negative c value, comma 0, or 0, comma plus or minus the c value, are going to be the coordinate points of those foci. Okay. So here we have a horizontally defined ellipse. The major axis would be this length here, the x. The minor axis would be the y here. The foci are on the inside on the major axis. The vertices are the endpoints on the major axis. And if it's vertical, all that stuff is still on the major axis. It's just that the major axis this time is the vertical axis. But the vertices are on the endpoints of that. The foci are on the major axis. Our minor axis in this case is this horizontal distance that we have stretched. Okay, so we need to figure out the orientation of the ellipse, and then we should be able to find all the information about it pretty quickly. So let's jump into an example. We have an equation of an ellipse. It's x squared over 9 plus y squared over 4 equals 1. We want to find the foci, the vertices, the length of the major and minor axes, and then we're going to sketch the graph. I think that the easiest thing to do when you are to do all of this information about ellipse is to actually sketch the graph. So the way I'm going to do that is I'm going to look at the numbers underneath x and y, and I'm going to do the square roots of those numbers, and that is how far we're going to go out in that direction from the origin. So underneath x I have 9. So if I do the square root of 9, I get 3. That tells me that I'm going to extend a distance of 3 in both directions on the x-axis. Okay, and then for y, the number underneath y is 4. That tells me that our stretch is going to be 2, the square root of that, in each direction. Okay, so just do the square roots of the numbers on bottom. That's how far you extend out. I now have 4 points for my ellipse, so I could go ahead and graph that ellipse, which I'm going to go ahead and do. Which means, let me try that again, that we're going to get an ellipse that looks something like that. Okay, now I'll go through and find all the information so that you can see where that information is located here. The foci, we're going to use our formula that c squared equals a squared minus b squared. So remember what I said we're going to do is we're just going to take the numbers on bottom and we're going to subtract them big minus small. So 9 minus 4, that gives us 5. So if c squared is equal to 5, that means that c is the positive and negative square root of 5, which means that our foci are the coordinate points plus and minus the square root of 5, comma 0. Now I know that this is an x coordinate here because it is stretched more in the x direction. My major axis is my x axis in this case. So those foci have to occur on the x axis. Again, plus and minus root 5 comma 0. If I wanted to plot those, root 5 is slightly bigger than 2, right? So if I go out just a little bit bigger than 2, I'm going to have a focus here and a focus here on the major axis, right? They're just inside of the ellipse, slightly bigger than an x-coordinate of 2 there. The vertices, the rest of this is pretty easy. The vertices are the coordinate points on the end point of your ellipse where it's stretched the most. So it's stretched most in the x, and those endpoints are positive and negative 3. The length of the major axis, well, that's what is this total length of this axis that we have stretched here. That total length is 6. I went out 3 in each direction, and the length of the minor axis would be the length here, which would be 4. Okay, so all that information is pretty easy to find. The only part that takes a little bit of work is finding the foci there, and then understanding if it's an x-coordinate or a y-coordinate. That determines the orientation of our ellipse. I'm going to go to Desmos just really quickly and then come back to the notes. Here I've created the equation of an ellipse, x squared over a squared plus y squared over b squared equals 1. Now this is a horizontally defined ellipse, which is just what we had. A was 3 because the number underneath that was 9, and b was 2 because the number underneath y squared was 4. So I've got a being 3 and b being 2. The foci here is, this number is the square root of 5. And then I'm plotting those as I graph this. So this is what our ellipse looked like, and our foci here were at negative root 5 comma 0 and positive root 5 comma 0. Okay, next equation looks a little bit different, right? I don't have denominators going on. So what I want to do is I always want my equation to equal 1 on the right side. If I can get my equation equal to 1, then I can look at the denominators, and that tells me a lot about the equation. So what I'm going to do on number 2 here is I'm going to divide everything by 144. And if I divide everything by 144, then I'm going to get 1 on the right side. So all I need to do is reduce 16 over 144. 16 over 144 is 1/9. So I'm going to get x squared over 9 plus 9 over 144 is going to reduce to 1 over 16. So y squared over 16 equals 1. Now I can look at this as my equation of my ellipse, and I can find all that information here. So it just ask me to find the foci. So c squared is going to be 16 minus 9. Again, do the bigger number minus the smaller number every time. So c squared is 7, so c will equal plus and minus the square root of 7. Now because the number underneath y is bigger in this case, that means it's going to be stretched more vertically, which means the foci need to occur on the major axis, and those are going to be 0, comma, plus or minus the square root of 7. It's going to be a y-coordinate now. If I wanted to find all that information, the vertices would be 0, comma, how far would I stretch it in the y, because that's the bigger stretch here, which would be 4. And then the length of the major axis, if I stretch it 4 vertically each way, my length there is going to be 8, and the length of my minor axis, I'm going to stretch it 3 in each direction horizontally, so that's going to be 6 as the length of my minor axis. Okay, so this one's going to be oriented vertically. Again, I'll go ahead and plot those points. So I've got 4 and negative 4 on the y-axis. I have 3 and negative 3 on the x-axis. see if I can do a better job this time of creating this ellipse. Okay, it looks something like that. And then the foci are plus and minus root 7. Root 7 is a number between 2 and 3. And so that's going to occur on the major axis, which in this case is the y-axis. So I have a focus here and another focus here. Okay, last one. Now we're actually given the coordinate points, and we want to figure out the equation. So if I know that the vertices are at plus and minus 4, 0, that tells me a few things. First of all, I'm going to go ahead and write x squared over plus y squared over equals 1. I know it's going to look like that form. I just have to figure out what the numbers are here. Well, my vertices are x coordinates, which means that my stretch in the x is going to be my major axis, and that stretch is 4 to each side, which means I'm going to square that number, and that's going to go underneath x. If it were 0, plus or minus 4, that 16 would go underneath y. Okay, so I know I'm going to have x squared over 16. Now I need to figure out what this number is, which is going to be b squared. But what I do have are the coordinates of the foci. So I know that A is 4, and I know that C is 2. So if I think about my equation for the foci, it's C squared equals A squared minus B squared. I know that I'm going to have 2 squared equals 4 squared minus B squared, which means we have 4 equals 16 minus B squared, which means that B squared is going to be 12. Now I could solve for b. b is going to be the square root of 12, but what goes underneath, if you think about our equation, it's over a squared and over b squared, which means that 12 is going to be the number underneath y. So this is our equation. And then if I wanted to graph that, again, I'm going to go a stretch of 4 on the x in each direction, and a stretch of the square root of 12 in each direction on the y-axis. So the square root of 12 would be somewhere around 3.5. So I'm going to go out 3.5-ish on the y-axis, and it's going to look something like that. And then I will try my best here to make this happen with my ellipse. So it's going to look something like that. Okay, a little bit more circular this time. Something to consider, we'll make another video about this, but something to consider is think about what's happening to the shape of our ellipse depending on the numbers a squared and b squared. If those numbers are really far apart, what's that mean your ellipse is going to look like? If those numbers are really close together, what would that mean that your ellipse is going to look like? And how does that affect where the foci are? So I'll show you really quickly in Desmos using some sliders here. If I make a stretch out even more, this is going to make it more stretched out. But look at the foci, right? Those get really close to the endpoints on your major axis there. So this would be an equation. If I made this, let me take this back to just 8. If I made it A8, that would be x squared over 64 equals y squared over 4. So a much bigger number for A than for B. And notice how far out those foci get. If I bring A back and I make it really close to B, look at what happens to the foci. They get further and further away from the vertices until, well, now we have a perfect circle, and the focus, I just have a single focus here in the middle. But that's a conversation for a different day. So just think about those numbers and how that's going to affect the shape of your ellipse.